Section 4.2 deals with using intercepts. Intercepts are really important things that occur on our graphs that we are going to focus on in today's lesson. So before we get there, we need to do our warm-up, and we are solving these equations. Okay, so be careful with the problems like numbers 4 and 5, where we have variables on both sides, and number 3, we've got some fractions involved. Okay, so take your time, solve each of these equations for the indicated variable. All right, so please make sure you check over your answers. 1 and 2 were relatively basic. We had those plus zeros there, which mean absolutely nothing. So you'll see I crossed them off on each and solved for the variable that remained. Number 3, my approach may have been different than your approach. You may have just used your calculator and inverse operations, which is completely fine dealing with those fractions. I decided to take a 10, multiply it through the whole entire equation, because 10 is the LCD, or the least common denominator, of all these fractions. When multiplying a 10 into each of these terms, I have 40 over 5 times x plus 10 over 10 equals 90 over 10, because this 10 will multiply into the numerator of each. I can then simplify each of those fractions, and now we are left with only whole numbers. So then 8x plus 1 equals 9. And then we just solve that two-step equation. Number 4, we had x's on both sides. 2x is bigger than negative 3x, so I moved the negative 3x to join the 2x by adding 3x to both sides. And number 5, we had y's on both sides. 7y is bigger than negative 5y, so I added 5y to both sides to bring all of our variables on the right side. I ended up with negative 1/2 equals y, which means y equals negative 1/2, or negative 0.5. I'm fine with decimals as long as they are terminating decimals, meaning they stop. Okay, so the main ideas for today's lesson: we will be able to use x and y intercepts and interpret their meanings in real-world situations, and to use x and y intercepts to graph lines. So what is an x and y intercept? Well, the y-intercept is the y-coordinate of where the graph literally crosses and hits the y-axis, the vertical axis. Now, the cool thing about this is everywhere on the y-axis, the x is always 0. Okay, so let me scroll down here. I don't particularly like that graph. So if I look over here on number 1, and I ask you to define each of these points that are on the y-axis. So if I say, well, what would be this ordered pair right here? Well, you would say it's 0, 1. If I ask you what's this point, you would say that's 0, 2. X is 0, y is 2. If I go down here, what's this point? Well, x is still 0, y is negative 1. So when we look at this, everywhere on the y-axis, no matter what point we pick, the x-coordinate is always 0. Okay, so that's why with this definition up here, the y-intercept is the y-coordinate of the point where the graph intersects the y-axis, and the x-coordinate is always 0, like we just displayed. What about the x-intercept? Well, the x-intercept is the x-coordinate of the point where the graph intersects the x-axis, and at this location, the y-coordinate is always 0. So I'm going to go down here. I'm going to go to graph 2, this example, and we're just going to pick some ordered pairs that are on the x-axis. Okay, so right here, okay, this ordered pair is 2, 0. Our next ordered pair is 3, 0. Going over here, that's negative 1, 0. Over here, negative 3, 0. X is negative 3, Y is 0. So at all these ordered pairs that are located on the x-axis, the y coordinate is always 0. So for the y-intercepts, it's only y's, therefore x is 0. For x-intercepts, it's only x's, so y is always 0. Okay, so here's an example, and I didn't want to use this with the definitions just due to the fact that we are only in the bottom right quadrant of our coordinate plane. But it does display x and y intercepts. Okay, so in this model it says the x-intercept is 4. It represents the time that the diver reaches the surface or when the depth is 0. So if we look at our axes labels, again, it's going to be really important to know what your labels represent. So the x-axis represents time. Okay, so 4 minutes. The y-axis represents elevation. So at 4 minutes, the elevation is 0, therefore the depth is 0. Okay, looking at our y-intercept. Okay, it's the order pair 0, negative 120. So at time of 0 minutes, the elevation or the depth is negative 120 feet. Okay, so the y-intercept is negative 120, which represents the diver's elevation at the start of when he starts to go up, or when time equals 0. So whenever time equals 0, that represents the start. So let's take a look at our first two examples, which we kind of looked at a little bit, but we want to just literally answer the questions to find the x and y intercepts. Okay, so where does it cross the x-axis? Where does it cross the y-axis? So let's use, I'll use blue for x. So the x-intercept, we want to go to the x-axis and figure out where it crosses. Well, it crosses right here. What is that x value? Well, the x value is negative 1, negative 2. So the x-intercept is negative 2, which is represented by the ordered pair. X is negative 2, y is 0. If we're talking the y-intercept, where does it cross the y-axis? Well, go to our y's, start at 0, 1, 2, 3. So our y-intercept is 3, which is the ordered pair. X in this case is 0, y is 3, so 0, 3. If we look at number 2, where does it cross the x-axis? What is the x-intercept? Okay, so we want to locate where it crosses the x, which is right here, which is negative 2. So the x-intercept is negative 2, or the ordered pair, we need the x value to be negative 2, therefore y is 0. For our y-intercept, go to the y-axis. Where does it cross? Well, it crosses at positive 1. So the y-intercept is 1, which would be the ordered pair. We need y to be 1, so x is 0, y is 1. So for our next problems here, we're going to find the x and y intercepts of an actual equation. And this is where we need to take into account that y-intercepts occur where x is 0, which is on the y-axis, and x-intercepts occur where y is 0, which is on the x-axis. So you'll see in the model that in order to find the x-intercept, we're going to replace y with 0 and solve for x. So in order to find the x-intercepts, we only want x's. So the y's, we say, see you later. When we plug 0 in for y, it just goes away. So we'll end up with the 5x equals 10, and then we solve so x is 2, giving us an x-intercept of 2. In order to find the y-intercepts, we're going to replace x with 0 and solve for y. So for y-intercepts, we want only y's, so make those x terms go away. So by plugging 0 in for x, it makes the x's go away. We're then left here with negative 2y equals 10. Divide by negative 2, so our y-intercept is negative 5. Okay, so in example 3, if we want to find the x-intercept, it means we make y go away, so y equals 0. So be like, oh, see you later. We end up with a negative 3x equals 30. We then divide both sides by negative 3 in order to solve for x. And we get x equals negative 10. So our x int is negative 10, or the ordered pair, x is negative 10, y is 0. In order to find our y-intercepts, remember that's where we make x go away, x equals 0. So if we kind of consider the equation, the original equation as it was, now say, oh, we only want y's, so let's make the x's go away. So now we're left with 5y equals 30. So we divide both sides by 5, and y equals 6. So that means our y-intercept is 6, which would be represented as the ordered pair 0, 6. So the y needs to be 6, therefore the x is 0. See how many of these problems we've got here. Not too many. Okay, so let's do the x-intercept of number 4 together, and then you can do the y-intercept of number 4 on your own. So x-intercept means see you later, y's. So now we're going to solve 4x equals 16. In order to solve, we would just divide both sides by 4. So x equals 4, which means the x-intercept equals 4, which is represented as the ordered pair 4, 0. Okay, now we want to pretend that we're back where we started with the original equation. I'm going to undo that. So if we want to find the y-intercept, what do we need to do? Plug in 0 for x, meaning make x go away, solve for y. What is your y-intercept? Okay, so when we make our x term go away, we cover that up. We're left with 2y equals 16. Divide both sides by 2, so y equals 8. So our y-intercept is 8, which means we go to the y-axis at 8, which is represented by the ordered pair 0, 8. All right, let's take a look at number 5. Trish can run the 200-meter dash in 25 seconds. The function f of x equals 200 minus 8x gives the distance remaining to be run after x seconds. Graph this function and find the intercepts. What does each intercept represent? All right, so let's let the word problem do the work for us. Okay, so the distance remaining to be run after x seconds. So x represents number of seconds. So let's start there. So we're going to take that x value, label the number of seconds, and we're going to put it right on our coordinate plane over here. So number of seconds, or we can, let's go time in seconds. It's a little more sophisticated. We'll fix it up here. So time in seconds. And it's also telling us what the overall value is then telling us. It says the function f of x equals 200 minus 8x gives the distance remaining to be run. So that means our y value, or f of x, is the distance remaining, okay, or the distance to finish line. So I'm going to write it down here. F of x, or y, equals distance remaining. To finish. And that is in meters. Okay, so I'm going to go to my y-axis, and I'm going to label it distance remaining. And it's in meters, so I'm going to indicate that by that little m. All right, and the overall graph here is representing the 200-meter dash, or Trish's 200-meter dash. Okay, so x is the time that she's run, and y is the distance remaining to the finish line. So it gave us our x values to use to plug and chug. So let's plug these in. So if x is 0, and here's our function, so I'll write that down here. So f of x equals 200 minus 8x. We're plugging in 0 for x. Okay, so we can just kind of ignore this f of x part. It just means y, and whatever we get after plugging in the 0 for x is the y value when x is 0. So when I plug in 0, if I PEMDAS, 8 times 0 is 0, 200 minus 0 is 200. So we've got 200 when x is 0. When x is 5, we're just doing all this. You can do it as side work. If you want to make a different table, I don't care. We're plugging 5 in for x. So we're literally doing 200 minus 8 times 5. Well, 8 times 5 is 40. 200 minus 40 is 160. But if you type this right here into your calculator exactly as is, you're going to get the correct answer. So this is going to give us 160 when x was 5. Now we're going to plug in 10 for x. So if I do 200 minus 8 times 10, again, you type that into your calculator exactly as is. 8 times 10 is 80. 200 minus 80 is 120. Okay, so when x is 10, y is 120. Next, we're plugging in 20 for x. Okay, so this is just kind of our side work down here. If I plug in 20, 200 minus 8 times 20, typing that into our calculator, that's going to give us 40. And then if I do the 200 minus 8 times 25, 8 times 25, that's going to give us 200, so that's going to be 0. All right, so let's plot these ordered pairs. Okay, so here we have the ordered pair. I'm going to try to make nice points here. X is 0, y is 200. Oh, look at that. That's our y-intercept, because the y-intercept occurs where x is 0. Next, 5, 160. So x is 5-ish, 160-ish. So this is going to be a ballpark. So we need to be a little short of 6 for x, and we'll be somewhere around here for the y. 10, 120. So when x is 10, y is 120. Again, it's not always going to be ideal in terms of our graphing, but do your best. Next, we're going to be at x is 20, y is 40. So just shy of 21, underneath the 50 here. And then x is 25, y is 0. So 25 is x, y is 0, so that's going to be a nice one. Okay, so let's connect those points. Now, even though we had to kind of estimate these points, I do have two nice ones. The 0, 200, and the 25, 0 are nice, and kind of missed our mark with a couple of them, but that's okay, because these are just estimations because we don't have perfect points here. So I'll even kind of erase these. All right, so what is this graph displaying? Well, the x-axis is time in seconds, and the y-axis is the distance remaining. So let's not try to recreate the wheel, and let's just describe what's happening. So if the time is 0, it means she didn't even start running yet. Okay, so if the time is 0, she didn't start running, she's at a distance of 200 meters from the starting line. Okay, so the race is literally 200 meters. Okay, so at the starting line, Trish is 200 meters from the finish. Time equals 0. Okay, so she didn't start running yet. Now, what about the x-intercept? Okay, so this was technically our y-intercept. What about the x-intercept? Well, at the x-intercept is 25, 0. So let's talk about that. So x-intercept, if the time is 25 seconds and the distance remaining is 0, that would mean it takes her 25 seconds to reach the finish line. So she runs the 200-meter dash in 25 seconds, and that's exactly what it said. Okay, so let me write my ordered pair for the y-intercept. That was 0, 200. So time of 0 means we are 200 meters from the finish line. So at the starting line, Trish is 200 meters from the finish line. And the x-intercept is 25, 0, which means it takes Trish 25 seconds to reach the finish line. Okay, so using these labels will help us. Let's take a look at number 6. We might as well do this one together as well because it does take some time getting used to the interpretation. Number 6 says the school sells pens for $2 and notebooks for $3. The equation 2x plus 3y equals 60 describes the number of pens, x, and notebooks, y, that you can buy for $60. Graph the function and find its intercepts. Okay, so let's get started here. So let's identify what our x and y represent. So our x represents number of pens, and number of notebooks is our y. So let's kind of spell that out. Okay, so let x equal number of pens, y equals number of notebooks. So let's put that on our coordinate plane. So x is number of pens, y is number of notebooks, and the overall scenario is our supplies for $60. Now, here's a little tip. Technically speaking, in order to make a line, you only need 2 points. Now, due to the fact that it's literally telling us to find its intercepts, if I find the x-intercept, that's 1 point, and the y-intercept, that's a 2nd point, technically I have my 2 points in order to graph my line. So let's do it. So I'm going to write my function, 2x plus 3y equals 60. Let's find x-intercept first. So if I'm finding my x-intercept, that means I'm making my y go away. Y is 0. So I'm only going to write 2x plus, well, plus nothing, equals 60. Okay, because again, we are pretending that y is 0, y is going away. So see you later, we're solving 2x equals 60. So when I do that, I then end up dividing both sides by 2. So I get x equals 30. So my x-intercept equals 30, or the ordered pair 30, 0. Now if I'm going to find my y-intercept, that's where we need to make x equal 0. X is going to go away, so we're going to pretend x is going away. That means I'm going to solve this equation, 3y equals 60. So I divide both sides by 3. So I have y equals 20, which means my y-intercept equals 20, or the ordered pair 0, 20. So let's plot those 2 points. So the x-intercept is 30, 0. So 30 on the x, 0 on the y. My y-intercept is 0, 20, so we're going to go to 20 on the y. Now I'm going to use my straight edge and connect my points. All right, so what does this mean? Well, let's interpret. So it says to graph the function and find its intercepts. Now, here's the thing. In this particular situation, we're not going to go beyond each of our intercepts because we only have a set fixed amount of money. Okay, and we're not going to buy negative pens. We're not going to buy negative numbers of notebooks. So what do these intercepts actually represent? Well, if we put some labels with each of these ordered pairs, if our x-intercept is the ordered pair 30, 0, that means we can buy 30 what? 30's label is pens if we buy 0 notebooks. Well, let's talk about the y-intercept now. The y-intercept is the ordered pair 0, 20. So if x is 0, so if we buy 0 pens, we can buy 20 notebooks. Now I came up with these conclusions just by simply using our axes labels. Now, are you going to buy only pens or only notebooks? No, but any point on this line, let me see if I can get a little highlighter. Any point on this line will represent a possible number of combinations of pens and notebooks that can be purchased. Okay, so a very nice ordered pair here that actually happens to fall in a crosshair is x is 15, y is 10. Okay, so we could buy 15 pens and 10 notebooks for the $60. So we could buy any combination of pens and notebooks of any ordered pair on this line. The X and Y intercepts just simply represent maxing out only pens and only notebooks. Okay, so this particular idea just kind of says, oh, okay, we really only need 2 ordered pairs to graph a line. Previously, we pretty much used 5 most of the time. And it's easiest to just find the intercepts, okay, by making X go away to find the Y intercept, make Y go away to find the X intercept. All right, so that's what we're going to do in our last 3 problems here for today's lesson. Okay, so we're going to use our intercepts to graph the line described by the equation. Now, if we are using intercepts, the easiest way to go about doing this is to put each of these equations in what we call standard form. Okay, and we talked about standard form in section 4.1. So we want to write in ax plus by equals c form. X and Y are together. It just makes life a little bit easier for these particular problems. So, if I look at number 7, let me try to adjust my pens here. Number 7 says y equals negative x plus 4. So because x and y aren't together, I want to bring them together first. So let's first add x to both sides, which leaves me with the equation. I've got y plus x, or x plus y would be the same thing. I write it up here, equals 4. So again, that's just easier to work with. Now, if I'm going to find my x-intercept, I'm going to make y go away. Okay, so I'm just going to do my scribble out of the y, but then I'll kind of undo it. Well, if I make y go away, all I have now is x equals 4. So that's my x-intercept, x equals 4. So our x-intercept equals 4, which is the ordered pair 4 for the x, 0 for the y. For the y-intercept, remember we want only y's. So let's pretend we're making the x go away. Well, what remains? It just says y equals 4. Okay, there's my y-intercept. So my y-intercept equals 4, which y is 4, so x is 0. So we only need to plot those 2 points, connect it with a straight edge, and because this is just a generic equation, there's no real life situation, we are going to put arrows on the ends. Okay, so we're going to plot these 2 ordered pairs. So 4 on the x-axis, so an x-intercept of 4 means just go to 4 on the x-axis. 1, 2, 3, 4. Y-intercept of 4 means go to 4 on the y. 1, 2, 3, 4. And now we can graph our line. Let's see. Okay, make sure you have your line going through your ordered pairs as best you can. And it does continue on in both directions. Ooh, that's a really big one. Okay, any point on this line will make this equation true. We'll do number 9 together, and I'm going to save number 8 for you. Number 9 says y equals 1/3 x minus 2. So we want to use our intercepts to graph, and it's easiest if we have it in ax plus by equals c form, which means I want to bring the x over with the y. So in order to accomplish that, let's just subtract 1/3 x from both sides. And I like x's to be in front of the y's when I write an equation, so I'm going to write this as negative 1/3 x, and that's a positive y, so it'll say plus y equals negative 2. So that's the equation that I'm going to work with. Okay, now, in order to find the x-intercept, it means make y go away. So I'm going to scribble out the y. Okay, so what do we do now? Well, it says negative 1/3 x equals negative 2. So let's write that. Oops, I want to make that scribble go away. So negative 1/3 x equals negative 2. So in order to undo this, this is the same as saying, I can put this x up here. I can write this as negative x over 3 equals negative 2. So I'm dividing by a 3 and there's a negative there. So I can look at that as dividing by negative 3. So I'm going to multiply both sides by negative 3. Because the negatives will cancel each other out and the 3's will cancel each other out. So we're going to end up with x equals 6. So our x-intercept is 6. And that ordered pair is 6, 0. For the y-intercept, we want to make x go away. We want only y's. So if I scribble out the x's here, what do I have? I have y equals negative 2. Well, that one's already done right away. So y equals negative 2. So our y-intercept is negative 2, which is the ordered pair 0, negative 2. All right, so we're going to plot those two ordered pairs on our coordinate plane, and then we can draw our line. So the x-intercept was positive 6. So go to 1, 2, 3, 4, 5, 6 on the x-axis. And the y-intercept was negative 2. Go down 2 on the y. And now we get our straight edge, your ruler. And draw your line through your 2 points and put arrows on the end to indicate that it does continue on forever. I'd like you to do number 8 to finish it up. Okay, so we already have it in ax plus by equals c form. So make your y go away to find your x-intercept. Make your x go away to find your y-intercept and graph. In solving for your intercepts in number 8, when I make my y's go away to find my x-intercepts, I end up with negative 3x equals negative 12, giving us an x-intercept of 4, or the ordered pair 4, 0. When I make my x's go away in order to solve for my y-intercepts, I end up with y equals negative 3. So I go to negative 3 on my y, positive 4 on my x, plot those two ordered pairs, draw our line, and make sure we show that the line does continue on forever. Please make sure that you use the models in these notes in order to complete your lesson quiz. Okay, and especially number 2. We've got x's and y's on different sides. If we want to use our intercepts to graph, please make sure that you bring that y term over to join the x term.